So this is the beta lesson for 3.5. It is the derivatives of the trig function. So we left off with this last week. We left off with the derivative of sine is cosine. And in the book, derivation's a little needy because it's based on something in chapter 8. So we essentially took their word from it from a picture. The derivative of sine is the cosine, the derivative of the cosine is the negative sine. That's as far as we got last week in the alpha lesson. So if we want to do the derivative of the tangent, the cotangent, the secant, and the cosecant, we just do the quotient rule. Now, it's important that you write these derivatives in that array of the trig functions. Get written in an array. It's not optional. I don't like to see people write them down the page vertically. There's a reason we organize this. Sine, cosine. Well, sine divided by cosine is tangent. And then across from these are the reciprocal functions. And when we get to the end of chapter 3, and we have to do the inverse, derivative of the inverse functions, that array is going to be helpful to you. You used it earlier in the chapter. So we'll just do this one. The derivative of tan, which if you're looking in the book on page 144 at the bottom and 145 at the top, they tell you what they are. But it's just using the quotient rule. So if I go over here, trying to get this camera straightened out, even though it's backwards. Go over here. I want to take the derivative with respect to x of tan, which is sine x over cosine x. Yes, I understand what being asked, because that's what the tangent is by definition. To do the quotient rule, the derivative of this, we take the denominator and square it, and then paste the denominator in the numerator. Practice with the quotient rule. So far, so good? Times the derivative of the top. The derivative of sine is cosine. Subtract the top, which is sine, times the derivative of the bottom. You end up with cosine squared x, subtract a negative or plus a positive, sine squared x over cosine squared x, and the numerator is the Pythagorean identity. So you get 1 over cosine squared x, which is 1 over secant times secant. Well, I'm sorry, this is secant times secant, which is secant squared x, which is the derivative of tangent. Then what? We could get these the same way. The way we get them is rewriting all of them in terms of sine and cosine and doing the quotient. And that's good practice, but you don't need to do it. You need to do this. You need to memorize the answers or the derivatives in the array. Now, a couple of prompts. Dave Bigeman was here a couple years ago, and his idea was if the function starts with a c, the derivative is negative. That's pretty good. Remember? Begins with a c, the derivative is negative. And somebody sent this thing to me last year. I don't remember who did it. I should have given them a shout out. But the problem is, for this thing to work, this table down here, you have to memorize the table. So, I mean, but it's interesting. So we're here. It's a cover-up method. So if I want the derivative of the secant, let's do the derivative of tan. We already just did. So if I want the derivative of tan, I cover it up. Cover up that column. What's the derivative of tan? Secant, secant, which is secant squared. What's under the tan? Cotangent. What's the derivative of that? Negative times a positive, and negative cosecant squared. So if you cover up the column that has the parent graph that you want the derivative of, it's the product of the other two columns is the derivative. That's just like that doesn't replace using the quotient rule to do the derivation. It's just a so working to read. Okay? So, example 4. In example 4, we're on page, excuse me, 145, and there's a picture in the book. Now, they want, I'm not going to draw this on the calculator because there's a picture in the book of tan x divided by x, and you have 3 branches of that graph. You have 3 branches of that graph. If I want the derivative, you could use the quotient rule. But right here, you're just doing it with the calculator. So you do this on your calculator. Ready? You go to Y1. You got to make sure you're in radio mode. You go to Y1 and type tan x close parentheses divided by x. And you turn on numerical derivative, whichever line you had that in, y5 or y6. Make sense? And you get a table set. And you start at 2. You should get this output. Meaning, the tangent of 2 radians divided by 2 is this value, truncated to 3 places. And the derivative of this by the calculator is this value. If you don't have that, you may be in degree mode. I can't see of any other reason why you wouldn't have that. So now what? The pre-image of the tangent line, this is the instantaneous change. It's the slope. So the pre-image would be y equals this times x. And I slide it 2 to the right, down here by doing the opposite. And that is the tangent line. The normal line is not a big deal. They ask you for this, you should be able to do it. You won't see normal lines in the EP test. What happens? The product of the tangent and normal lines is -1. So what do you multiply this by to give you -1? Negative reciprocal of that. And that's the same magnitude for the slide. Okay? And in the book, you see this picture down here in the corner on page 145 where the graph is in black, the tangent line's in red, and the normal line's in blue. So the tangent line is red, it has a positive slope. The normal line is in blue, it has a negative slope, just as we have here. Okay? So that's your model. I'm going to pause the video, and everybody's going to go to problem 23, please. All right, so we're going to go over problem 23. There's a picture up here. Now, I used the calculator. And the value of the derivative at 3 is this number. It's a -8 and 63 thousandths, around 3 places. Okay? The value of the function at 3 is this. So the -8 is your slope. What are you doing? You're sliding it 3 to the right, up 1 and 27 hundredths, 270 thousandths. That's the tangent. The normal line is the opposite of 1 over this. So in the picture, it's hard to see it in this window. This line here is the normal line, and the tangent's hitting the graph right there. But the issue is, you're finding the value of the derivative at that point, which is telling you the slope of the tangent line for that input. And then you're just doing the opposite, to slide it to the right, and in this case, up 1.27. Okay. Example number 5 is a second derivative. So we can do second derivatives, same way we did first derivative. Ready? So this secant, the parent graph is 1 over the cosine. So to get the derivative, we would do the quotient rule. But we're concerned about the second derivative, so we're just going to skip to the second derivative. Because we saw in the textbook, derivative secant is secant tan from the quotient. For the second derivative of this, I got to take the derivative of this. So how do you do that? Product rule. First term, secant times the derivative of tan, which is secant squared, plus tan, second factor, times the derivative of the secant, which is secant tan. Combine your like terms. On this side of the addition sign, secant times secant squared is secant cubed. On this side, you have tan squared times secant. That would be the second derivative. So in order to get the second derivative, you're kind of looking back to that table on page 145. Because you're not going to do all of this by the quotient rule each time. You can do the quotient rule once through that table, you're good. But you're literally memorizing it. It's not that complicated. We're not going to have you memorize that much. But for you not to memorize the trig functions would be a handicap in the spring, because most kids have them memorized. And the kid that you're competing against is 2 questions ahead of you if you're trying to derive something with a quotient. Okay. So we're going to leave that up there. I'm going to send you to do problem number 36. Now I'm going to warn you, 36 is harder than example 5. So for today, we're going to be content if you could do 2 things. Do the first derivative and follow my solution for the second derivative. Everybody should be able to do the first derivative. What's going on with problem 36? They're using a theta. Who cares whether you use x or theta? You just differentiate with respect to theta. So if it helps you, you can rewrite that as an x if you want. That's just an input. So the best case scenario is you can find the first and second derivative. I don't really expect people to do that today. If you can find the first derivative and follow the second one, that's good. If you can find the first derivative and you get lost somewhere in the second, that's probably expected, but you can work your way through it. So if you're at home, we're going to pause this while you go to calculate the second derivative, or the first and second derivative, for problem number all right, so let's see if we can follow what's on here. Here's what you got. Parent graph, stated tan theta. What the derivative does with respect to theta. Y depends upon theta. If I take the first term, which is theta, times through the second term, secant squared theta. Plus the derivative of the first term will be a 1. Derivative of theta with respect to theta will be 1, tan theta. That's the first derivative. To get the second derivative, differentiate this. So what? Well, this is the sum. The sum of derivative of the sum of the derivative. But this one's way easier to do than that one, so I just put that over here. Derivative of tan is secant squared. It's the left side of the addition sign. What I got? The derivative of theta secant squared theta would be theta, the first term times the derivative of secant secant, plus secant squared, the second term times the theta. So I have this theta right here, times the first term secant times root of secant, which is secant tan. Plus, ready? The second term, which is secant times root of first term, which is secant tan. Plus this secant squared theta times root of theta b1. So these two add up to this. Define your like terms, and you're here. You got this far, you're good. What happened from here down is we rewrote everything in terms of sine and cosine. The only issue with that is it's a multiple choice question, and all of the choices have sine and cosine. You would have to end up, if it is at the bottom, but if you got this far, that's really good. Which is 2 theta secant squared theta tan theta plus 2 secant squared theta. Right. Now, here's what's going to happen. If you are at home, what can happen is I'm going to stop the video.